In Module 3, Lesson 18, we're going to solve some more problems on area and circumference. So in the opening exercise, we're asked to draw a circle with a diameter of 12 centimeters and a square of a side length 12 centimeters on grid paper, and then determine the area of the circle and the square. So I'll leave drawing the circle on the grid paper to you, and we'll calculate the area of the circle and we'll approximate would be radius squared, and our radius is 6. So the square of 6 is 36 times 3.14. And the area of that circle is approximately equal to 113 400ths, and these are square centimeters. And the square is the side length squared, so 12 squared is 144 square centimeters. Then we're asked to brainstorm some methods for finding half the area of the square and half the area of the circle. I would divide them each in half. And we're asked then to actually find the area of half of the square and half of the circle, and explain to a partner how we did that. And then we're asked to make a ratio of the new area to the original area for the square and for the circle. So then in looking back, if they want me to make a ratio of the new area to the original area for the square and for the circle, there's no place where they ask me to approximate. So I went back and did our area in terms of pi for both the circle and half of the circle. And now we'll write a ratio of the new area, which is half of the circle and half of the square. (18 pi) over 36 pi that's our circle, and then our square is 72 to 144. If we simplify those ratios, we would find that each of them represents 1/2, 1 to 2. So if we continue on exploring, they're asking us to find the area of 1/4 of the square in the circle, first by folding and then by another method. You have Hopefully, you have centimeter paper that you have drawn your circle on. So you may be able to explore it by counting the squares. 1/4 of the square and the circle, of course, would be, the circle would be 9 pi. Square centimeters. And the square is 36 square centimeters. And the ratio of the new area to the original area would be 9 pi to 36 pi. Again, they are square centimeters. And 36 to 144, which is again square centimeters. And if you simplify these, you again get 1/4 for each one. And the whole point of our activity then is to write an algebraic expression to express the area of a semicircle and the area of a quarter circle. So a semicircle, which is half of a circle, would be 1/2 times radius squared times pi. And quarter circle would be 1/4 times radius squared times pi. Which should make perfect sense. But oftentimes when we're stuck in the middle of a problem, things that make sense don't always occur to us. So then in example 1, we're going to practice using those new formulas to find semicircle areas and quarter circle areas. So if I have the semicircle with a diameter of 14 centimeters, our radius is 7, so we'll do 7 squared times pi, and we'll need to find 1/4 of that, or 1/2 of that, sorry. 1/2 times 7 squared times pi. We do the calculation. We end up with 24.5 times pi square centimeters, which is our exact measurement, or approximately 77 square centimeters, and I rounded to the nearest square centimeter. In the quarter circle, they've given us the radius, and so our formula is 1/4 times our radius squared, which is 6 squared, times pi, or 9 pi square centimeters. And if we do an exact calculation, or approximation, I'm sorry, it would be approximately equal to 28 square centimeters. And again, I'm rounding to the nearest square centimeter, or actually I rounded up. I rounded. Example 2, which is more like the kind of problem that we'll see in the real world. We have Marjorie, who's designing a new set of placemats for her dining room table. She sketched a drawing of the placemat on graph paper, and the diagram represents the area of the placemat consisting of a rectangle and 2 semicircles at either end. Each square on the grid measures 4 inches in length. We need to find the area of the placemat and explain our thinking regarding the solution to the problem. So if Marjorie wants to make 6 placemats, how many square inches of fabric will she need? All right, first of all, let's find the area of one placemat. So what we have is, first of all, a rectangle and that rectangle, remember, each square on the grid is 4 inches in length. So 1, 2, 3 times 4 is 12. That's our length. 12 by 1, 2, which is 8. Remember, each one is 4 inches in length. So 12 times 8 is 96 square inches. And then the semicircles. Now before we do too much work, if I take these 2 semicircles and I put them together, they would have a diameter of 8, a radius of 4, and they would create one full circle. So if we simply find the area of the circle, rather than finding the area of each semicircle, we'll have the full area of these 2 pieces. So our formula for area of the circle is radius squared, and that radius was 4, so 4 squared, which is 16, times pi, and again, these are inches squared. Now, I would say in this particular situation that an exact measurement isn't really going to help Marjorie, because she can't go to the store and talk about 16 pi. So in this situation, we really do have to multiply and approximate the actual square inches. So 16 times 3.14 is 50, approximately 50 square inches. Altogether, we're going to add together the 96 and so a total is 146 and 24 square inches per placemat. If she wants to make 6 placemats, how many square inches of fabric will she need? We multiply that times 6, and we find 877 and 4,400 square inches. Marjorie decides that she wants to sew on a contrasting band of material around the edge of the placemats. How much binding material will Marjorie need? Now, if she's going to sew around the outside, we are no longer talking about area, we're talking about perimeter. And this is a special perimeter because we have the two rectangular lengths, but we don't have the rectangular widths because she is not binding around the center of this placemat. She is, however, binding around the outside of these two semicircles, which if we add together would be the circumference of one circle. So we'll need to calculate the circumference of the circle. And if you remember, the formula for circumference was diameter times pi. Our diameter, that's the whole way across, was 8. So we have 8 times 3.14, which is 25 and 1200ths, and these are inches. And then we have the two long sides, which were 12 each, so 24 for the long sides. And we add those two measurements together, and get 49 and 1200ths inches per placemat. And she has 6 placemats that she wants to make, so we'll need to take that and multiply it times 6, and she will need 294 and 7200ths inches of binding material. Honestly, binding material is not sold in inches. It is sold in yards. So if we're going to go to the store, what we really need to do is convert 294 and 7200ths inches into yards. We do that by dividing by 36 inches in a yard. So what she really needs is 8, and I'll round to the nearest hundredth, and 1900ths yards. And she would want to make sure that she rounded up a little bit. So more than likely, when she goes to the store, she'll need to make sure that she gets 9 yards of binding material in order to complete the project. In example 3, the circumference of a circle is 24 pi centimeters. We want to find what the exact area of the circle is. Now I'm going to let you draw the diagram this time, but what I'm going to do is work backwards. I know that circumference, 24 pi, is equal to diameter times pi. So then I know that the diameter of this circle is 24. To find the area, I need the radius. Remember, area equals radius squared times pi. So my radius then is 12. I would do 12 squared times pi, which is the exact area of the circle. Go ahead and multiply 144 pi. And these are square centimeters. And of course, as usual, I did the work before reading the questions. So let's practice. First, we're asked to find the area of a circle with a diameter of 42 centimeters, and we're going to use 22/7 as the approximation for pi. So if the diameter is 42, we need radius squared times pi. Our radius is 21 centimeters. Using that information now, we're going to square the radius and multiply times pi. So 21 squared is 441. And then multiplying times 22/7 will give us approximately 1,386 square centimeters. In number 2, they tell us that the circumference of a circle is 9 pi centimeters. So if the circumference of a circle is 9 pi, then the diameter, remember it's diameter times pi, our diameter then is 9, which means that our radius will be half of that, which is 4.5. And then our area would be radius squared, which is 20 and 25/100 times pi. And these are centimeters squared. If students only know the radius of a circle, what other measures could they determine? Well, you can definitely find the diameter. You could find the circumference, right? The diameter is 2 times the radius. The circumference is 2 times the radius times pi, and you could find the area, which is radius squared times pi. And of course you can find a semicircle and a quarter circle from them as well. And in our final problem, they ask us to find the area in the rectangle between the two quarter circles if AF is 7 feet, FB is 9 feet, HD is 7 feet, and we're going to use 22/7 as the approximation for pi. So again, we're going to find the area in the rectangle between the two quarter circles. So this space in between the two quarter circles. First of all, let's determine what our initial shape is. It appears to be, it's definitely a quadrilateral. It appears to be a rectangle, but either way, if we're looking for area, whether it is a parallelogram or a rectangle, we would find that area by multiplying length times width. So the first thing we need to determine is what is the length. A to F is 7 feet, and F to B is 9 feet, so our length is 16 feet. We'll label that first. 16 feet. Our width, up and down, they're saying that HD is 7 feet. We know that AF is 7 feet, and so since this is a a quarter circle, we know that AH is also 7 feet. They are both radii of the circle. So this is 7, and HD is 7, and that means that the width is 14 feet. 7 plus 7 is 14. Remember, this is for our rectangle. So if we find the area of the rectangle, which is 16 times 14, that's 224 square feet. We'll label that and move on. Now our next step then is to find the area of the 2 quarter circles. If I put 2 quarter circles together, I get a half circle. So let's just go right ahead and find the area of the semicircle that these two pieces make up. It's 1/2 times the radius squared times pi. So our radius squared, the radius was 7 feet. That's 49 times pi. In this case, we're approximating pi with 22/7. So now what we'll do is the calculation. 1/2 times 49 times 22/7. And we get 77, approximately 77 square feet. For the 2 quarter circles put together. Now in our final step then, we'll need to subtract the area of those 2 quarter circles, and that will give us 147 square feet, which is the space in between the 2 quarter circles.